Hello all. So we have already discussed about the first lecture under the basics of non-parametric test with application by R, and there I told you that non-parametric test generally made on the rank statistics. So this lecture will deliver that what does it mean by rank statistic. So for this lecture 2, our primary concern is to learn rank and permutation. So the concept covered in this lecture are ranks, permutation and inverse permutation, probability distribution of rank. So suppose it is possible to arrange the individuals according to the degree to which they possess a character under inquiry. Such ordered arrangement is called a ranking. So when I am saying ranking, that means I am having some concept on the ordering. Okay, order and rank, these are synonymous. But sometimes we have to order in increasing order, in increasing manner, ascending manner. Sometimes we order in descending manner. Generally, in statistics, when we are saying the ranked observation, that means the observations are arranged in ascending order. Mark this point. Now, the ordinal number which indicates the relative position of the observation is called rank of the individual. So, how to ranking your data? Order the observations in the data from lowest to highest. I told you that generally in statistics, ordering is done in ascending order from lowest to the highest. Based on the order, this numerical position is the rank of that particular observation. Tied observations are also there. There might be the repetition of the observations. Then those observations, we will say that these are the tied observations. You have to break the tie to have the rank. So kind of averaging of the ranks, and this process is called tie breaking. We will see in a short while what does it mean by tie breaking. Now let us have a quick example. Data comprises 6 observations. So can you see 32, 39, 12, 7, 98 and 56. First is very simple. Try to arrange all these observations in ascending order, that means from the smallest to the largest. 7, 12, 32, 39, 56 and 98. So what will be the rank? Look at the position. Where does 7 occur? 7 occur in the first place. So the rank of this observation 7 is 1. Rank of 12 is 2. Therefore, you will have 6 rank. 6 observation, 6 ranks. So you have to remember this is a very simple fact that if you have n observations, then your highest rank will be n and your lowest rank will be 1. Let us have one more example. Now for this example, you will see the repetition. 5 is being repeated. Clear? So -1, 5, 5, 0, 7, 9, 3, 3, 3. So 3, 3, 3, these are the repeated observations. So we will say the tie occurs. Tie of length 2 for 5, tie of length 3 for 3. So when you are arranging these observations in ascending order, it's very easy. -1, 0, 3, 3, 3, 5, 5, 7 and 9. So how to assign rank? For the first 2 observations, having rank is very easy. -1 is the smallest one. That means the rank will be 1. And 0 is the second smallest. The rank is 2. Now just have a look over this process. This is called average ranking or rank tie breaking. Tie breaking. Average ranking means for these three, we are assigning rank 3. Then the next 3, we are assigning rank 4. And for the third 3, we are assigning rank 5. So altogether 3 ranks, 3 consecutive ranks. 3 plus 4 plus 5 divided by 3. I told you this is sort of averaging. So 3 plus 4 plus 5 divided by 3, that will bring you down with the average rank as 4. So for 3, the rank will be 4. There are 3, that means 4, 4 and 4. Can you see? This 4 is for the rank for 3. For the next 3, the rank remains the same. For the next to next 3, the ranks remains the same. Similarly, for 5 and 5, the rank of tie of order 2, you can just have count after 5, that is 6 and 7. Is that clear? So the first one, -1 is rank 1, then 2, then 3, then 4, then 5. Make a halt here. For this 5, the counting again starts, and it will start by 6 and 7. So 2 cases, 6 plus 7 divided by 2, that will be 6.5 and 6.5. For this 7, the rank will be 8, because again we will count right after 7. So the rank will be 8, and after 8, 9. Clear? So this process is called the tie breaking process. So in RStudio, there are 3 basic inbuilt packages. Base are stats and mass, and every package has the rank function. You can go from sorting and ranking, and don't forget to mention the tie method. There are few other way of tie breaking which are uses, like maximum or minimum, like this, but here we will be using the average. Okay, so I'm going to the R in a short while, so let me show you R. Okay, so the last lecture already I have introduced you with the RStudio quadrant, and in fact in packages, as I have already mentioned, there are mass, stats. There are 2 types of packages in the library, package library of RStudio. One is user packages and another is system library, okay, the inbuilt packages. So you will find that base, mass and stats, all these packages which I already told you in this system library packages. In case you are in need of any package, then what you can do, you can just install that package. Can you see that install button here? Install package from your R repository CRAN. For that you need to have the internet connection. So whenever you will write the name of the packages here, that will directly download from the internet. Okay. So let me come to that rank thing. Suppose you have that X means the observations. In R, as you know, generally we write the observation in terms of C. C means combining, okay, C. It is a vector format, -1, 0, 3, 3, 3, 5, 5, 9, 7. Already we have done this in this previous slide. Now how R will do it? You can run this and sort this observation. Can you see? The R has done the sorting from the smallest to the largest. Now use the rank function, rank bracket X ties dot method. That is very, very essential. This is called the tie breaking method. Tie dot method, that is average. So in R you will find there are more. Okay, let me show you something so that you people will take interest. So whenever I am writing rank, see I am using the console rank. Can you see this pop-up menu, rank of X. Look at the ties method. It is C. How many types of tie breaking method R can use? Average, first, last, random, max and min. These are all things. So in case you are choosing, okay, X, and let me write ties dot method. Remember, whenever you are writing, you have to write within the quote max. Okay. So now enter. So what you will find? -1, it has rank 1, 0, rank 2. Now 3, it should be rank 3, 4 and 5, and we have done the averaging. But since I have chosen max, R will assigning the maximum rank for 3. So what is the maximum rank for 3? 3, 3, 3, 5. So 5. For 5 also the maximum rank 6, 7. So 7 is the maximum rank to be assigned for the 5, 9 and 8. But we are not going into this type of nitty-gritty. Let us to stick to the average ranking method, because that is what we have to use during the statistical calculation. So let me run this rank, and you will have the method. The rank is 6.5, 6.5. One question might trigger in your mind that, well, rank should be an integer, but why 6.5, 6.5? This is not an integer will come up, because we are doing the average. So for this we can have mixed number like 6.5. Clear? Okay. So if y is this observation, the rank of y, how to run this? y1. So run this y1, you will have the result 3 to 1. Okay, the rank of y, 3 observation, 3 to 1, and the rank will be 3 to 1. So for 3, rank is 3, for 2, rank is 2, for 1, rank is 1. Probability distribution of rank statistics. By now, you can understand that rank is a statistic. Rank is a function of the sample observation. It depends on the observations which you have collected. Okay. So for a data set, say x1, x2, xn, ranking makes them n ordered statistics as x1 less than x2 less than xn. Have you seen that ranked observations are generally written in terms of x bracket 1, x bracket 2, x bracket n, and this bracket terminology is called the ordered observation. So when I am writing x bracket r, that means I am pointing out to the rth order observation, and that r is the rank of the observations. So order statistics are obviously neither independent nor identically distributed. Why? Because you are ordering. One observation is bigger than the previous observation. So when you are imposing this type of ordering, then they cannot be independent in nature. Joint distribution of n ordered statistics, x1 less than x2 less than xn, is not the same as the joint distribution of simple x1, x2, xn, right? So for ordered statistics, the joint distribution is different. Okay, let us have a quick and particular example. Suppose there are 3 observations, very easy, 3 observations, x1, x2, x3. So what are the possible arrangement, or what are the possible ranks one can think of? First observation might have rank 1, second observation has rank 2, and the third observation has rank 3. Similarly, first observation might have rank 2. First observation might be bigger than the second observation. So in that case, second observation has the rank 1. Third observation has rank 3. So basically, if you juggle with 1, 2, 3, so what we are doing, we are just swapping 1, 2, 3 in different place. First observation means the first place, second observation means the second place, and the third observation means the third place. So we are juggling between 1, 2, 3. So how many possible arrangements you can think of? Altogether 6 possible arrangements you can think of, right? So how these 6 comes up? 6 comes up by 3 into 2 into 1. First place, first rank can be taken by any of the 3. So 3 ways. The second place or the second rank can be taken by the remaining 2. So into 2, and the final one can be taken by 1. So 1. This is a clear-cut case of combinatorics. I am not going into that details of permutation combination. I am just trying to give you a very basic idea. So here you will see 1 2 3, 1 3 2, 2 1 3, 2 3 1, 3 1 2 and 3 2 1. The first means that R1, okay, R1 means the rank 1, rank for the first observation 1, the rank of the second observation as 2, rank of the third observation as 3. So when it is 1 2 3, we call that ranking as natural permutation. Okay. So if I ask you what is probability, look at this part. What is probability? R is your statistic, your rank, is equal to small r. Have you seen there is one under bar? That means R is your R1, R2, R3, and that is equal to particular choice. Let's say 1 3 2. Let's say this 1 3 2. So what will be the probability? What is the chance? Very easy to calculate out. You have 6 possible cases and you are choosing 1. So 1 by 6. In general, this is 1 by n factorial. Now what is n factorial? N factorial means n into n minus 1 into n minus 2 into 3 into 2 into 1. So 3 factorial means 1 into 2 into 3, that means 6. So that's how that 6 comes up. So permutation and inverse permutations, already you have a slight idea regarding permutation. Rank is also a permutation, an arrangement. Permutation is an arrangement of the number in specific order like 3 1 2, 1 2 3, etc. And inverse permutation is very interesting, is a permutation in which each number and the number of the place which it occupies are exchanged. That means each number and the number of the place which it occupies are exchanged. Suppose for this permutation 3 1 2, 3 occupies the first place. In its inverse permutation, 1 will be placed at the third place. So 3 at the first place, so 1 will be at the third place, just the interchanging. Element 1 is at second place, and in inverse permutation 2 will be placed at the first place. So it's very interesting. Okay, the place and the number, they are changing their position, exchanging their position. So 3 1 2, it has the inverse permutation 2 3 1. Similarly, I will ask you to try on your own. Suppose you are given with a permutation 2 3 4 5 1. Is the inverse permutation for this permutation is 5 1 2 3 4? Do you believe that? Check yourself. For a natural ordering 1 2 3, inverse permutation is itself, means even if you are trying to have the inverse permutation of 1 2 3, that will bring back the same permutation 1 2 3. A permutation and its inverse permutation have the same probability distribution, and there lies the importance of studying the inverse permutation. Ranking of observations is the permutation which maintains a specific order. I told you ranking means greater than in ascending order. So, two consecutive observations must hold the inequality like greater than, like less than. But when you are anti-ranking or when you are doing permutation, inverse permutation means anti-ranking. Okay, you are You are just sorting out the rank. You are not holding that particular arrangement. That's why it is called anti-ranking. Okay. So when you are doing inverse permutation, the observations remains the same, but they are not holding such type of inequality. Therefore, the distribution, probability distribution finding in inverse permutation is easier than the probability distribution of ranked observation. So finding probability distribution of test statistic, we need unranked observation which can be achieved through inverse permutation. That's why in non-parametric statistics, you have to do ranking first and then you have to do the anti-ranking. So these are the references once again, that the non-parametric statistical inferences by J.D. Gibbons and S. Chakraborty, and the fundamentals of statistics by Athindra Mohan Gun, Milan Kumar Gupta and B. Dasgupta, World Press. I would suggest you, for the beginners like you, you can just stick to the fundamentals of statistics. It is a very, very neatly written and with some understandability. So I would personally recommend you to go through this book. So in this lecture, we learned rank, permutation and inverse permutation. Next we learn measures of association between two variables based on the corresponding ranks. Thank you.